This is suppose that pool of water at equator. We are representing this at equator. And here it is eastern side of equator. This is western side of equator. So 5 degree north of equator to the 5 degrees south of equator, we find that ocean current flows east to west. It flows from east to west. North equatorial current, south equatorial current. Now combinedly they carry huge volumes of water to the western margin. Right? Huge water, क्योंकि मैंने कल एक हिंट दिया था कि कितना वॉल्यूम होता है इसका ओशन करंट्स का. Collectively they keep on carrying the water to the western part. इसको मैं ऐसे भी कह सकता हूं that both currents merge towards western part of ocean. They don't collide, they don't move head on. Right? Collision नहीं होता है, लेकिन दोनों का पानी एक साथ वेस्टर्न ब्लॉक में वेस्टर्न साइड में एक्यूमुलेट होता है. Understandable? Can I also add one point जो अभी नहीं पढ़ा आपने बट ऐसा कॉमन पॉइंट है. It will also be having slightly higher content of salt क्योंकि सरफेस पे salinity होता है. So it keeps moving towards west. There will be addition of salt water and lot of piling. Because of this factor, some of the water actually sinks and moves in backward direction. This is subsurface. जो अभी तक देख रहे थे वो कहां पर हो रहा है? सरफेस पर. Maximum impact up to 100 meters. This is happening below 100 meters or approximately under 100 meters. कुछ पानी वापस चलने लगता है. क्यों पानी वापस चलेगा? Just a compensatory effect. Just the compensation that water goes towards one side, accumulates there. तो वहां पर पानी का प्रेशर होगा ना, वेट बढ़ेगा पानी का, और सॉल्ट भी ऐड हो रहा है तो डेंसिटी बढ़ेगा पानी का. Because of that, water goes underneath and moves in backward direction. The current is not a very strong. ये जो backward movement है बहुत strong current नहीं है. Volume इसका बिल्कुल 10% 20% of the surface current है. Not very high. Not so much that it even reaches to the center or eastern part of the ocean. It stays there itself. It travels for a few kilometers and then vanishes. This is called as counter equatorial current. The current is counter to equatorial currents. दोनों में clash नहीं होगा. क्यों clash नहीं होगा? Elevations अलग अलग हैं. One is moving at the surface, another is moving below the surface, subsurface. So they're not going opposite to each other. Instead, one is moving west to east, another is going from east to west. कोई ज्यादा clash नहीं होगा. Height दोनों का अलग अलग है. So how does counter current flow? West to east. And how is surface current flowing? East to west. अब देखो west to east लेके जाने के लिए इसके पास support नहीं है. The water that goes from west to east, there is no major support. No wind will act at 100 meters of depth. Rotation of earth will also not have a major influence. The only reason why this current has been generated at equator is the piling of water on the western margin. ये दोनों currents के merger से ये backward flow हुआ है. Am I clear with this? Counter equatorial current. Previous year question में चलते हैं. एक question आता है. The statement of the question was very interesting. Question पूछा गया, the counter equatorial current that flows from west to east is because of option A was rotation of earth, option 2 था merger of two currents, C or D was out of the question. मतलब वो कोई दिक्कत वाली बात नहीं. अब पहले पॉइंट को क्यों उन्होंने कहा? See, when you see this counter equatorial current, statement of question क्या था? The counter equatorial current that goes west to east. Most of us thought west to east, rotation of earth is west to east. तो पहला ऑप्शन काफी लोगों ने मार्क किया करेक्ट. जबकि एग्जैक्ट रीजन क्या है? What is the main reason? Merger of ocean currents on the western margin. Therefore, counter current is generated. Some people also applied extra amount of thinking क्योंकि overthinking prelims में सबसे खतरनाक है. सबसे ज्यादा अफसोस पता किन क्वेश्चंस को होगा? जहां पर आप ज्यादा सोचने लगते हैं. What did they do that time? काफी लोगों से मेरी बात हुई थी जब उन्होंने क्वेश्चन देखा. उन्होंने सोचा कि ओशन करंट ठीक है ईस्ट टू वेस्ट जा रहा है, तो ईस्ट टू वेस्ट इज आल्सो कैन ड्यू टू रोटेशन ऑफ अर्थ, बिकॉज रोटेशन ऑफ अर्थ इज फ्रॉम वेस्ट टू ईस्ट, तो सरफेस करंट गोज फ्रॉम ईस्ट टू वेस्ट एंड देन इट सिंक्स एंड कम्स बैक. जबकि डायरेक्ट रीजन क्या था? merger of two currents. Clear? So counter current is generated because of these two factors. Two currents merging on the western part. क्योंकि सिर्फ पानी ही accumulate नहीं हो रहा है ना, salt भी accumulate हो रहा है, और salt accumulate होने से density increase होता है. Okay? अच्छा, तीनों oceans में सबसे strong counter current कहां बनेगा? Which oceans has the strongest counter current? The one that is larger, right? Because greater volumes of water will be accumulated on western margin. जितना बड़ा ओशन उतना ज्यादा पानी accumulate होता है वेस्ट पे, and it becomes counter current. right? It is there in Indian Ocean, it is there in Atlantic Ocean. Sure. Sometimes अच्छा इसको लॉक करूं मैं. So when you see this map in your atlases and everywhere, you find यहाँ पर एक counter current mention किया होगा. Is it mentioned? Counter current. Let us suppose it is the region of Pacific Ocean. These are Indonesian islands. Sumatra, Java, Bali, Lombok, Sulawesi, East Timor, suppose Borneo. South of that is Australia. Pacific Ocean का कौन सा part है? Which coast of Pacific Ocean? Western margin of Pacific Ocean. Along the eastern margin of Pacific Ocean is South America and North America. Something like this. Chill. And here we have, this is the equatorial region. We are correct with this? Dhyan se sunna. Now here we have the current. What is that? North equatorial current and south equatorial current carrying water volume, huge volumes of water to the western side of Pacific Ocean. पानी का level यहाँ increase हुआ. To compensate that extra piling of water, there is some water movement exactly in backward direction at equator. We call it as counter equatorial current. Look at it. So in a pool of water, if you're continuously flipping water to one side or making it to oscillate a bit, when it touches the one corner of the pool, it comes back subsurface, much like a swimmer swimming across the pool, then takes that somersault or backward. So it remains under the surface for some time. The swimmer will remain under the surface for some time. Counter current का भी कुछ ऐसा ही कहानी है कि surface current ने water masses को west में ले लिया, पानी का level increase हुआ, बहुत pressure पड़ा और कुछ backward flow होने लगा. Clear? Now the same current here, south equatorial current, इसको हमने क्या कहा था? East Australian current, and towards the western margin of South America is the Peru current, or it is Humboldt current, cold current, because of which there is a desert formation. This is the arrangement in which part of Pacific Ocean? Southern part of Pacific Ocean. Clear? Everyone is clear with these ocean currents? No problems? अब बस एक बात मानना मेरी, बाकी आप छोड़ दो. Sometimes the counter current becomes very strong. कभी कभी ये counter current बहुत strong बना, and it behaves just like the normal current. It behaves just like the surface current. Why does it become strong? There is no reason known so far. At least मुझे तो reason नहीं मिला कहीं पर. अगर आपको मिले तो please share. But there is no reason that we know. This counter current becomes quite strong and behaves just like the surface current. Surface current means it is as strong as a surface current, and it manages to reach to the coast of Peru and Chile. Because west to east चलेगा तो कहां तक पहुंचा ये? Peru तक पहुंचेगा. Chile, western coast of South America it reaches. If the surface current is weak, obviously East Australian current is also weak. If the East Australian current is weak, Peru current also gets weaker. After all, यही पानी कहां तक पहुंचता है? Peru तक पहुंचा. तो अगर surface current ही वैसा नहीं चल रहा है, it is not flowing east to west. Instead, the surface current is moving west to east. It reaches to the coast of Peru. I'm repeating this point. We do not know why counter current is getting stronger, but we can see what happens because of that. Counter current strong हो चुका है, and it goes from west to east in the Pacific Ocean. So strong that it manages to reach to the coast of South America. Okay, and there is circulation of equatorial waters. If it's an equatorial water, the temperature of this water masses should be higher. क्योंकि इक्वेटर से जो भी पानी आया टेम्परेचर ज्यादा ही होना है उसका. If temperature is higher, then there can be some rainfall, evaporation, water masses, etc. So Peruvian coast, Chile coast has circulation of warm water, therefore rainfall. कहां पर बारिश हो रही है? जो अभी तक हम अटाकामा डेजर्ट कह रहे थे, उस अटाकामा डेजर्ट के आसपास बारिश हो रहा है. Are we getting this point? Counter current के कारण Eastern Pacific is abnormally warmer. And this phenomena is more common, more often in the month of December, and it's a Christmas celebration there. और याद रखिए, it is in southern hemisphere. इनका summer time है ये. It's a summer time for southern hemisphere. Christmas, New Year, December, उनके लिए celebration time है, and therefore it rains in that time. So imagine it's a peak summer time, celebration है और बारिश भी हो गया. So locals called it as blessing of Christ, named it as El Nino. Understanding? Some people even call it as little boy. El Nino, literal meaning of El Nino in Spanish is little boy. They call it as baby Jesus. Some they call it as child of Christ. ऐसे करके नाम देते हैं वहां पर, because it is just like a blessing for them. Desert में बारिश हो रहा है और कितने साल बाद? लगभग 3 से 4 साल बाद. This phenomena, this El Nino, occurs 3 to 4 years. अभी 2023 El Nino year था. So what happens in this El Nino year is the eastern Pacific Ocean is abnormally warmer than western Pacific Ocean. Normal circulation क्या होगा? कहां पर गर्म पानी आना चाहिए? ऑस्ट्रेलिया की तरफ, इंडोनेशिया की तरफ. यहां पर कहां पानी हो रहा है? पेरू की तरफ. बस इतना ही El Nino. Abnormal heating of eastern Pacific, whereas western Pacific remains cooler. What happens because of that abnormal heating of Pacific, eastern Pacific? Rainfall in Peru and Chile, which are relatively known for desert condition. पूरा चिली का रीजन नहीं, नॉर्दर्न चिली, अटकामा रीजन में बारिश हो गया. मैं लॉक करूं इसको. Understanding what is meant by El Nino. वो little boy क्यों कह रहे हैं? Why the Spanish name El Nino in the region? Because Spanish colonies say they speak Spanish there, so that's why term is Spanish. It is a subsurface current coming to the surface now. It is almost like, even if it is subsurface, है ना, तो 100 meters क्या 200 meters तक what sun rays तो आती हैं. That's called as photic zone. So even if it is subsurface, the temperature of the air mass, the temperature of the water is going to be higher, because there will be sun rays reaching up to that depth. But ऐसा नहीं होता. They become just like the surface current. अब आप रीजन जानेंगे क्यों काउंटर करंट स्ट्रांग होता है, तो एटलीस्ट आई हैव नो सोर्स फॉर इट जो मैं आपको बता पाऊं कि क्यों काउंटर करंट स्ट्रांग होता है. कोचिंग इंस्टीट्यूट नोट्स विल टेल यू दैट इट इज weaker trade winds etc, but trade winds get weaker because of El Nino and then reinforce the effect. Trade winds का effect El Nino पर नहीं होगा. El Nino का primary effect trade winds पर होगा. So exactly we do not know, and why does it happen only 3rd to 4th year is still not known. But effect समझ में आता है हमें कि कहां इसका effect होगा. The point is not what is El Nino, वो तो आसान है. I mean it's okay, we can manage with this. The main challenge is what is the effect of El Nino. Effects of El Nino on monsoon, effect of El Nino on various phenomena of the world. We'll see those effects one by one. We are moving towards effects of El Nino. एक एक करके effect समझिए and use rather than this time. We'll use this. This is what is happening in El Nino. Eastern Pacific is getting abnormally heated than compared to Western Pacific. चलिए. तो अगर continuous बारिश होता रहा, Peru receives continuous rainfall because there is a circulation of warm water here. कुछ points समझ लो El Nino के बारे में. Number one, El Nino is not an overnight phenomenon. It's not even a monthly or a weekly phenomenon. It may, once El Nino occurs, there's an El Nino condition developed. What is El Nino condition? Eastern Pacific is warmer than Western Pacific. There is counter current stronger. Now it may extend for 6 months. It may extend for 1 year. It may extend for 2 years. We have had incident in the past, condition in the past, where El Nino triggers in the month of December and it was continued till February, March, April and so on. In fact, 2023 पूरा ही El Nino year था. Prior to that, such strong El Nino year was 2014-15, 13-14. वो एक strong El Nino. For the 2 years we had seen the impact of El Nino. So let's consider El Nino as a phenomena that sustains at least for 6 to 7 months. And sometimes it may extend for a year or so. क्योंकि एक बार जब conditions change हो गई ना, उसको वापस normal आने में पानी में बहुत time लगता है. We'll discuss about it. So let's suppose there's a continuous influx of warm water here. तो rainfall हो रहा है. अब सोचो desert में बारिश हो रही है, semi-arid regions में बारिश हो रही है. Suppose Rajasthan receives continuous rainfall. And suppose make average example दे रहा हूँ. Delhi receives rainfall of about 60 centimeters, slightly less than 60 centimeters. Rajasthan, eastern Rajasthan is in 40 to 60 zone, and western Rajasthan is 20 to 40 zone, 20 to 40 centimeters in 1 year. Clear? Now suppose suddenly the rainfall in Rajasthan starts taking place on a higher scale and it goes not very high, 40 to 60 or 60 to 80 हो गया. और जहां 20 सेंटीमीटर होता है वहां पर सपोज 40 सेंटीमीटर बारिश हो गया, double the rainfall that it receives. Now if the 20 centimeter rainfall is like there's an increase of rainfall by 20 centimeter in Assam or northeast, it may not have influence, it may not have that impact. राजस्थान में वो 20 सेंटीमीटर का इंक्रीज एक स्ट्रॉन्ग इफेक्ट रखेगा. क्यों? क्योंकि वेजिटेशन नहीं है, क्लियर, क्योंकि चैनल्स नहीं है, सैंड है, it cannot absorb water and it will lead to flood like conditions. So रेगिस्तान में बारिश ओके है, बट बहुत बारिश और कंटिन्यूअस बारिश फ्लड भी ले आएगा. So suppose Assam receives a rainfall of around 150 centimeters, कुछ जगह 200 centimeter range में. Now Assam now receives 150 to 170 centimeter in a year. Will not have much influence. कोई major impact नहीं दिखेगा आपको, क्योंकि vegetation cover है, absorption होगा, इतने सारे rivers हैं, drainage हैं, and so on. Rajasthan doesn't have much natural drainage. So just a 10 or 15 centimeter increase in the rainfall may bring flood-like conditions. Can you understand this? अब वही पेरू में जहां पर अभी थोड़ी बहुत बारिश हुई थी, if it sustains, it will bring floods. So during El Nino years, first abnormality we see in the Peru and Chile itself. They experience flood-like conditions. Getting this? Whereas in the western part here, in Australia, Indonesia, कल मैंने एक बात emphasize किया था that East Australian current is very important for rainfall, etc. 90% population lives. Now they don't receive that influx of warm water; it's a cold water. Can rainfall occur here? No. क्या होगा? Droughts. So Indonesia, Australia, particularly northern Australia, experiences droughts, whereas Peru and Chile experiences floods. Understandable? Floods. Second point, Peru is known for fishing. Why? Upwelling होता है, right? Remember, Peru में fishing grounds not because of meeting of currents. Peru has fishing grounds because of upwelling of currents. बार बार इस पॉइंट पे स्ट्रेस देता हूं मैं, because it is very comfortable for us to remember mixing of currents. तो हमें लगता है जहां fishing grounds है वो इसलिए बना because there are mixing of currents. It is not the reason everywhere applicable. Here we see that upwelling of water happens in Peru. याद आया कुछ? Right? मैंने 600 NCERT का भी रेफरेंस दिया था. It is also mentioned there. Now will the upwelling happen now? No. Why? Because there's an influx of warm water. तो वो पेरू, वो चिले जहां पर fishing grounds बन रही थी, now they get warm water into them. Will there be upwelling of nutrients? No. So double loss हो रहा है पेरू और चिले को. What is that? Loss of fishing grounds. Fishing grounds are lost. You find a lot of mortality among fishes. Fishes die. क्यों? Why do they die? Because there's a sudden increase in the temperature. Plus there is no upward flow, upward movement of the water anymore. Nutrients fail to reach to the surface. They don't reach to the surface. So then it becomes double loss for Peru. Flood भी आया और दूसरा fishing grounds are also destroying it. Third effects बताने से पहले, should I trust you people for your memory? Yes or no? Sure? पक्का? अच्छा बताइए. One of the condition required for cyclone was wind shear. क्या था wind shear का point? Absence of wind shear. If the wind shear is high, first of all, what is wind shear? Change. Upper part is, change को छोड़ देते हम कहेंगे upper part is moving faster than the lower part. What happens because of wind shear? Moisture drifts away, and what happens to cyclone in that case? Cyclones are less formed if the wind shear is higher. ये point clear है everyone? अच्छा, let's see this point here. I use the same map. मुझे बताने की जरूरत नहीं होनी चाहिए. I should not be explaining to any of you that there will be increase in the cyclonic presence or occurrence in Eastern Pacific. You clear? Eastern Pacific में El Nino time पर ज्यादा cyclones आएंगे और hurricanes आएंगे. You remember that map? हमने कहा था cyclones occur on the eastern part of the continent. And there is only one exception where cyclones are frequent along western margin. That was the Central America or western part of South America. Remember everyone? Okay, you understood this? It comes back now. Why do we have more number of cyclones in Eastern Pacific during El Nino years? Because of presence of warm water. If there is more temperature or a very high temperature, the frequency of cyclone or hurricane is going to be higher. इसको explain करने की जरूरत नहीं है. You understand cyclones? We have already covered the discussion on cyclones. Why hurricanes are more here is because of there is extra heating of water, warm water. Therefore, it goes this way. अब ध्यान से सुनना इस बात को. What happens in a cyclone? Air rises, right? This we have this increase in temperature, air rises here, forms a low pressure conditions. What happens in upper part of the cyclone? Higher pressure. What happens from the high pressure? Air moves in dissipation, or it moves in away from high pressure. Low pressure में क्या होता है? It goes towards the low pressure and then has the circular movement. ऐसा ही होता है? Everyone clear? In the upper part of the cyclone, wind speed is higher, friction कम होगा. ध्यान से देखो आप. It is formed in Eastern Pacific, right? Eastern Pacific. Between Atlantic and Eastern Pacific, there is only Isthmus of Panama. कुछ थोड़ा सा like 70, 80, 100 kilometers का distance है. Or even if it is in Central America, doesn't make much of a difference. These winds which rise up can cross Central America and enter in which part? Atlantic Ocean. Repeating this point, ध्यान दीजिए. Air masses rise up here in Eastern Pacific. It forms higher pressure condition in upper part, and from high pressure winds deviate. तो obviously जो ये wind move कर रहा है, the speed of this wind is going to be higher. ऐसा हमने पढ़ा भी था that cyclones का अपना एक wind shear होता है. Upper part is circulating faster than the lower part. Now this fast flowing winds from the upper part of the cyclone enters in which ocean? Which ocean is this? Atlantic Ocean. So can I say the wind shear over Atlantic Ocean increases? अब क्या हो गया? Yes or no? दूसरे क्लासरूम में साइक्लोन है. There's a cyclone coming in this. कोई भी नाम दे सकते हैं आप, मेरे अलावा किसी का भी नाम दे दो, मुझे कोई फर्क नहीं पड़ेगा. उस क्लासरूम में एक साइक्लोन है. एयर इज राइजिंग अप देयर एंड द एयर इज पासिंग कमिंग टुवर्ड्स दिस क्लासरूम एज वेल. सडनली हमें लगेगा फ्रॉम द रूफ ऑफ दिस क्लासरूम देयर इज अ वेरी स्ट्रांग एयर ब्लोइंग आउट. दैट मींस द विंड shear इन द क्लासरूम हैज इंक्रीज्ड. लॉक करो इसको. सो वी कैन कंक्लूड फ्रॉम हियर, because the frequency of cyclone is higher in Eastern Pacific, rising air masses from upper part of cyclone deviate and increase wind shear in which ocean? Atlantic Ocean. Cyclones बनने चाहिए या नहीं? नहीं बनने चाहिए. We have less number of hurricanes in Atlantic Ocean during El Nino years and higher number of hurricanes in Eastern Pacific. So if I compare normal years with El Nino years, number of cyclones in normal years in Atlantic Ocean is very high. They reduce in number during El Nino years. क्या कारण है उसका? Wind shear. Now wind shear कैसे act करेगा? I'm repeating that point once again, that if there is higher rate of evaporation or vapors are there, wind shear will blow away those water vapors. They destroy cyclonic formation over Atlantic Ocean. लॉक करूं? अब इसी को क्वेश्चन में चेंज करके देखो जरा. Not in mains examination, prelims examination. Mains तो आसान है. You are supposed to write, you can write, you have 100 words, but prelims में क्या होता है ना कि उसी में से चूज करना है आपको, अपना दिमाग वहीं पे लगाना है. You don't have options, although there are 4 options, but you really don't have options to write. So I feel prelims is very, very difficult now. Because factual आता ना तो कोई बात नहीं, हम याद कर लेते कितने साइक्लोन एक साल में आते. They're asking why is it happening. See the statement. Suppose a statement is asked, frequency of hurricanes in or cyclones in Atlantic Ocean is less during normal years or is less during El Nino years. Can we understand reason why? Because wind shear is higher. अब ऐसे ही एक क्वेश्चन आ गया about the hurricanes in Atlantic Ocean. The question was asked, during normal years the frequency of cyclone is higher in Atlantic Ocean. Clear? अब आप इस तरह से सोचने लग जाएंगे उसको कि नॉर्मल ईयर में क्यों साइक्लोन्स बढ़ेगा. रादर हमें क्या सोचना चाहिए? एल नीनो ईयर्स में साइक्लोन्स कम क्यों होगा? Because having more number of a cyclone is a very normal phenomenon in Atlantic Ocean. Ocean current से इतना phenomenon. You don't have to think here why do number of cyclones increase during normal years. Instead, we should be focusing on why number of cyclone decrease in El Nino years. Okay with it? क्या कारण है? Wind shear. What generates that wind shear? Disturbances in Eastern Pacific. What creates that disturbance? Presence of warm water. What creates that warm water is counter equatorial current reaching here. What brings that counter equatorial current in this part of the year? Cross that. वो नहीं पता हमको. आगे बढ़े. Let's suppose none of us understood anything. कुछ भी नहीं पता. बस इतना हमें पता है that we have a summer in the north, at the same time there is winter in the south. Are we understanding this? Sunrays are in the north, slanting sunrays in the south. इतना तो clear है हमें. Okay. If this is the case that we have summer in the north, northern summers है, तो obviously sun rays are there in the northern hemisphere. तो low pressure कहां पर होगा? नॉर्दर्न हेमिस्फीयर में, लीव इवन ट्रॉपिक ऑफ कैंसर। सिर्फ एक बात ये क्या कहेंगे, दैट सनरेज आर वर्टिकल टू द नॉर्दर्न हेमिस्फीयर, समर इज देयर, टेम्परेचर इज हाई, तो वी हैव लो प्रेशर कंडीशंस। व्हाट अबाउट द सदर्न पार्ट? व्हाट अबाउट द सदर्न पार्ट? हियर देयर शुड बी हाई प्रेशर। मैं लैटिट्यूड भी मेंशन नहीं कर रहा, मैं सिर्फ ये कह रहा हूं सदर्न हेमिस्फीयर में हाई प्रेशर। व्हाई? बिकॉज इफ इट इज समर इन द नॉर्थ देयर विल बी विंटर इन द साउथ। विंटर है तो टेम्परेचर कम है, टेम्परेचर कम है तो एयर मासेस सिंक करेंगे एंड दैट विल फॉर्म हाई प्रेशर। So if I have to answer this one line question that what is required for southwest monsoon to occur, condition for southwest monsoon, one line answer है low pressure in the north hemisphere, so high pressure in the southern hemisphere. Then we'll go for specification की 20 degree north है या किस latitude में, छोड़ देते, यहां तक रखते हैं इसको। Second point is going to be that winds move from high pressure to low pressure. Is that clear to everyone? Till the wind is in southern hemisphere, the direction is southeast. Clear? But हमें ये पता है कि wind is moving from high to low. The low pressure is in which hemisphere? Northern hemisphere. तो obviously equator उनके लिए कोई मायने नहीं रखेगा. It will not have any significance for these winds. They'll cross equator and get deflected towards right. Coriolis force. So what do we call these winds as? Southwest winds. यहाँ पे लॉक करूं मैं इसको. India is somewhere here, so we get the southwest monsoon during summers. It's a condition that we have already covered. Okay. अब थोड़ा सा मैं लैंग्वेज को चेंज करूंगा एंड आई विल से दैट देयर इज अ रिक्वायरमेंट ऑफ प्रेशर ग्रेडियंट फोर्स और सिंपली प्रेशर ग्रेडियंट बिटवीन सदर्न हेमिस्फीयर एंड नॉर्दर्न हेमिस्फीयर। नो प्रॉब्लम्स विद दैट। लो प्रेशर इन द नॉर्थ, हाई प्रेशर इन सदर्न हेमिस्फीयर। अब आगे पढ़ के बस अब ध्यान रखिएगा, एवरीवन इज क्लियर विद द कंडीशन लास्ट टाइम? क्लियर? यू हैव दिस वेरी इंटरेस्टिंग फिनोमेना गोइंग ऑन इन सदर्न हेमिस्फीयर राइट नाउ एंड वी हैव वार्म वाटर इन ईस्टर्न पार्ट ऑफ पैसिफिक ओशन। अब देखो एक आध हफ्ते की बात होती तो शायद हम इतना डिस्कशन नहीं करते, बिकॉज इट सस्टेन फॉर मंथ्स। इमेजिन वॉल्यूम ऑफ वाटर दैट दीज करंट्स ब्रिंग टू द ईस्टर्न पार्ट, विल इट स्टे इन द ईस्टर्न पार्ट और स्प्रेड ओवर? स्प्रेड, बिकॉज एक जगह मोबिलिटी है पानी में, तो इट स्टार्ट स्प्रेडिंग इन अक्रॉस पैसिफिक ओशन, राइट? इट स्प्रेड्स ऑल अक्रॉस पैसिफिक ओशन डिपेंडिंग अपॉन द स्ट्रेंथ एंड द एक्सटेंट ऑफ द एल नीनो। इफ इट्स अ स्ट्रॉन्ग एल नीनो, 6 months, 7 months, 8 months, it is continuing. The warm water of eastern Pacific now spreads all across southern Pacific. Okay? Spreads all across southern Pacific. What is this? Warm water. कहां पर है? southern Pacific में. शुरू कब हुआ था? दिसंबर के टाइम पर. अब ये आ चुका है मार्च, अप्रैल, मई, जून का महीना है. June means their winter and northern summers. If I use the same map, so we should have the low pressure in the northern hemisphere. Low pressure in the northern hemisphere. What about southern hemisphere? क्या होना चाहिए? High pressure. Now, what will be the effect? आप बताइए क्या होगा? Low pressure बनेगा. कहां पर? Southern hemisphere में. Why low pressure in southern hemisphere? Because there is warm water. अब अगर southern hemisphere में या southern Pacific में गर्म पानी circulate कर रहा है, air in contact to that will also be warmer. Warmer air mass will tend to rise rather than sink. So this high pressure is weak. I'm not saying that the low pressure is formed. I'm just modifying it, saying that high pressure is weaker. पहले अगर 1030 MB का प्रेशर बनना था, अब ये 1020 पर रुक गया. Sure, it is still high pressure in the south, but not as intense high pressure as it used to be. क्यों ऐसा? Pacific Ocean is warmer. And again, say this over and again. Never estimate Pacific Ocean. अगर कोई स्पेस से हमको देखेगा ना, तो सबसे पहले उसको Pacific Ocean देखेगा. 1/3 of Earth is Pacific Ocean. If Pacific Ocean is warm, this will also have influence on southern part of the entire hemisphere. क्योंकि 1/3 of Pacific Ocean में अगर influence है ना, तो Indian Ocean में भी उसका कुछ ना कुछ impact दिखेगा. Atlantic में भी थोड़ा बहुत दिखेगा. Clear? And what is that effect? High pressure is weaker. If high pressure is weaker, what happens to pressure gradient force? Weak. तो ये जो winds चलती हैं, which southeast winds which become southwest winds, will they flow? Even if they flow, their intensity is going to be less. तो ये जो हमने यहाँ पर discussion ये कहा था, this high pressure is extremely weak high pressure, pressure gradient force decreases, तो winds चलेंगे लेकिन बहुत ही कम intensity के साथ चलेंगे. They'll be flowing with a very very low intensity, low speed, low volume. Lock करें? What will happen to Indian conditions then during El Nino years? Drought-like conditions. तो लिखने में एक लाइन में खत्म होगा. the El Nino conditions are leading to the drought-like condition in India because pressure gradient force is weaker. But why does it get weak? Is because southern hemisphere is abnormally warm. For monsoon to occur in India, we need a low pressure in the north and we need high pressure in southern hemisphere. अब वो high pressure नहीं बन पाया, क्यों नहीं बन पाया? क्योंकि गर्म पानी southern hemisphere में circulate करे जा रहा है. But if El Nino is very strong, जैसे 2019 में El Nino year आया था, very weak El Nino. By the month of March, everything was normal. But if it sustained like 2023, it sustained for a good number of months. That created drought-like conditions in some parts of India. Clear? ये point clear है? पक्का? If it is clear, then tell me what will be the effect on northeast monsoon. What is required for? पहले conditions पे जाओ. किन conditions में northeast monsoon आता है? Where do we have low pressure? In southern hemisphere. Everyone is convinced with this? Where do we have high pressure? In northern hemisphere. तो क्या होना चाहिए बताइए? I'll repeat for northeast monsoon. Northeast monsoon. Equator. सब कुछ भूल जाओ, कुछ नहीं हमें पता, बस इतना हमें पता है कि नॉर्थ ईस्ट मानसून के टाइम पर नॉर्दर्न हेमिस्फीयर में विंटर होता है. There are winter condition in northern hemisphere. If there are winter condition in northern hemisphere, can I say high pressure? In northern hemisphere, high pressure. If there are winter condition in northern hemisphere, क्या होगा southern में? Summer conditions, and therefore low pressure conditions. Sure, winds move from, they blow from high pressure to low pressure. छोड़िए प्रेशर बेल्ट्स को इग्नोर कर देते, बस सिर्फ सीजन्स पे जाएंगे. सदर्न हेमिस्फीयर इज वार्मर ड्यूरिंग दिसंबर or this winter time, and northern hemisphere is colder, high pressure. Winds move from high to low, deflect towards right. इनको क्या कहते हैं हम? Northeast winds or northeast monsoon. They won't, they will not stop at equator. They will cross equator and therefore get deflected towards right. Clear? Northeast monsoon becomes northwest for southern hemisphere. हम सिर्फ इंडिया स्पेसिफिक रहते हैं. इंडिया में विंड्स कैसे एंटर कर रही हैं? नॉर्थ ईस्ट. क्लियर? सो रिपीटिंग द कंडीशन फॉर नॉर्थ ईस्ट मॉनसून, रिट्रीटिंग मॉनसून, लो प्रेशर इन सदर्न हेमिस्फीयर, हाई प्रेशर इन नॉर्दर्न हेमिस्फीयर. साउथ वेस्ट मॉनसून में क्या देख रहे हैं आप? लो प्रेशर इन नॉर्दर्न हेमिस्फीयर, हाई प्रेशर इन सदर्न हेमिस्फीयर. सेम, ठीक उसका रिवर्स हो रहा है. इन सदर्न हेमिस्फीयर, सपोज इट्स एन एल नीनो ईयर and the Pacific Ocean is abnormally warmer. Yes, low pressure will further intensify. It will again decrease. What about the pressure gradient force? Increases. तो क्या होगा south northeast monsoon? Stronger, intense northeast monsoon. So during El Nino years, northeast monsoon is abnormally stronger than the normal years. क्यों ऐसा strong हो रहा है? समझ में आ रहा है कि low pressure जब shift हुआ south में, वहां already गर्मी है. The Pacific Ocean is quite warm. Because Pacific Ocean is warm, it will further reinforce low pressure, increase the pressure gradient force, winds blow with a higher intensity. Are we understanding this? Sure. एक एग्जांपल देता हूं. 2015 में that was an El Nino year, मतलब El Nino अब खत्म ही हो रहा था, लेकिन इफेक्ट अभी भी देखा जा रहा था. चेन्नई में फ्लड्स आते, तमिलनाडु, आंध्र प्रदेश experiences flood-like conditions. 2015, one of the devastating floods in Chennai were in 2015. न्यूज़पेपर क्या रेफरेंसेस दे रहा हूं मैं. न्यूज़पेपर्स दे कवर्ड इट. वैसे आपको लगता होगा कि 10 साल पुरानी बात बोल रहा है, मेरे लिए तो इट्स जस्ट कंटिन्यूइंग. आपको भी ऐसा लगेगा, बस एक साल और वेट करो, फिर आपके लिए भी कैलेंडर ही चेंज होगा, बाकी कुछ नहीं होगा. एनीवेज, सो यू फाइंड दिस 2015 देयर वाज अ हेवी रेनफॉल. न्यूज़पेपर आर्टिकल्स आई एम रेफरिंग टू, न्यूज़ वो जो कॉलम आता है उसमें, दैट ड्यूरिंग एल नीनो इयर्स नॉर्थ ईस्ट मॉनसून इज स्ट्रॉन्गर. रीजन बता रहे थे, मेट्रोलॉजिकल रीजन फॉर दैट, एंड दे मेंशन during El Nino years northeast monsoon is stronger. And rest, the reason of flood was mismanagement, lack of drainage system, blocked drainage, बाकी कहानी anthropogenic. Natural reason was this one. एक क्वेश्चन आता है प्रीवियस ईयर में, 2015 में शायद क्वेश्चन था. क्वेश्चन वाज asked, most of the unusual climatic happenings are due to El Nino. Understood the statement? Most of the unusual climatic happenings are due to El Nino. Can you justify the statement? What is unusual? पहला पॉइंट ही unusual है. Floods in a desert and drought in an equatorial country like Indonesia. Done. Southwest monsoon, जो main like 78% of rainfall that India receives is because southwest monsoon is weak. And which is stronger? Northeast. India doesn't get much of the benefit from the northeast monsoon except Coromandel coast. But then that is stronger and southwest monsoon is weak. It is abnormal. We have a very reduced frequency of hurricanes in Atlantic Ocean. Abnormal. लॉक करें यहां तक, एवरीवन रिलेट्स। आगे क्वेश्चन था, हाउ फार डू यू एग्री? Most of the unusual climatic happenings are due to El Nino. The second part of the question was, how far do you agree? बताइए, how far do you agree? Do you think that most of the unusual happenings are due to El Nino? Yes or no? Yes? Acha, answer this now. We had recent floods in California. सुना होगा आपने, ये टेक्सास में फ्लड आया, यूएस में, lot of floods. Was it because of El Nino? Or let's suppose heat domes, formation of heat domes in Canada, the heat waves in Canada, is it because of El Nino? No. Or let's suppose some unusual happenings like in Arctic Ocean, there are changes taking place. Is it because of El Nino? No. That is because of climate change. So answer किस तरफ जाना चाहिए अब? You cannot write yes we agree or no we don't agree. But in the last paragraph, towards the last paragraphs, in fact 2 paragraphs, you should be writing that there are unusual climatic happenings, as in you can name some of the unusual happenings जो उस साल की हुई है, जैसे heat waves in Canada is a prime discussion these days, or formation of frequent heat domes, or weakening of jet streams. These are unusual climatic happenings associated with the effect of climate change. In fact, climate change is intensifying El Nino like phenomena. ये तो ऐसा हुआ कि आपने सारा दोष किसको दे दिया? एल नीनो को दे दिया, और अमेरिकन को फ्री कर दिया, इंडस्ट्रियल नेशंस को फ्री कर दिया, और कहा कि नहीं, ऑल अनयूजुअल हैपनिंग इज बिकॉज ऑफ एल नीनो एंड क्लाइमेट चेंज इज नॉट कॉजिंग एनी अनयूजुअल हैपनिंग. तो क्लास लास्ट पे आपके आंसर्स में क्या दिखना चाहिए? दैट यू आर एसोसिएटिंग सम अनयूजुअल हैपनिंग्स ऑफ रिलेटेड टू क्लाइमेट विद क्लाइमेट चेंज. तो पहले जस्टिफाई करेंगे यस देयर आर सम अनयूजुअल हैपनिंग्स बिकॉज ऑफ एल नीनो, और फिर लिखेंगे क्लाइमेट चेंज is also responsible. In fact, climate change is mainly responsible for it.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.